Hello, my amazing students. This is Mrs. A, and I love math. And today, it's actually tonight, but I've been very busy trying to finish up my graduate class, and I just finished it today, and so I have time to do a couple of videos before I start the new class tomorrow. All right, so we're on lesson 99, uniform motion, unequal distances. Now in the past we've done equal distances, and now we're going to do unequal distances. And these are the types of pictures that we're going to see as models for unequal distances. So basically, person A has a distance, but then person P's distance is 50 more miles than distance A. And so we set up a relationship. So here would be our equation. Distance A plus 50 is distance P. And you can see it. Distance A plus 50 is distance P. So this is the scenario where two people start off at the same spot, but then one travels further than the other. Or you might see something like this, where P, distance person P, is traveling along, and then all of a sudden person A starts 50 miles after person P starts. So, but still, distance A plus 50 is the same as distance P. So that one equation will be the correct equation, whether they started at the same spot and then one went 50 more, or one went 50 and then the other one joined and they ended up at the same spot. You're going to have the same equation either way. So remember, distance is rate times time. So since we have distance of person A, we would have rate A and then times time A plus 50 is distance P. And so that's going to be distance P is rate times time. So rate of person P times time of person P. And this would be our equation that has rate and time in it. This would be our equation before we switch from distance to rate times time. So now we have our first example problem. At 8 p.m., Achilles left camp and headed south at 20 kilometers per hour. At 10 p.m., Patroclus headed south from the same camp. If Patroclus was 50 kilometers ahead at 3 a.m., what was his speed? All right, so here we have the same situation. Now they put some times in there. So Achilles left at 8 p.m. So I put 8 p.m. right there by Achilles. And then he was going 20 kilometers per hour. So we already know that. Then at 10 p.m., Patroclus headed south. So we're going to pretend this is south because I couldn't draw the arrows down very easily. I had too much writing. And then Patroclus was 50 miles ahead. So you see, this is Patroclus here, and he's 50 kilometers ahead at 3 a.m. What was his speed? So remember, we're going to say distance A, which is Achilles. So distance A plus 50 is going to equal distance P, Patroclus. Okay, so then we're going to put in distance is rate times time. So we're going to, instead of distance A, we're going to put rate A plus, times time, rate times time. Let me make that a little a because it's a subscript. Rate of A times time of A plus 50 is equal to, now distance is rate times time of Patroclus. So rate of Patroclus times time of Patroclus. Now, it really doesn't matter what time these are, except that we can tell the total time. So here we know that Achilles started at 8 p.m. and the race ends at 3 a.m. So that's 4 before midnight and 3 after, so 7 hours altogether. So Achilles' time is 7. So we're just going to go ahead and put 7 right there. And then Patroclus starts at 10 and goes to 3. So he started 2 hours later. That means his total time is 2 plus 3 is 5. So the time of Patroclus was 5 hours. You see how we're just putting in all of the things that we already know? And then we know something about a rate. We know Achilles' rate is 20 kilometers per hour. So right here I'm going to erase R sub A, and we're going to put 20 kilometers per hour there. Now guess what? We only have one unknown value. Now I'm going to use my little easy trick. Do you notice something that we can do that would make this a little bit easier? Can you see that there's a 5 in the 20 and a 5 in the 50 and a 5 over here by the rate? Okay, so you know what I'm going to do? I'm going to divide everything by 5. I divide 20 by 5, and I'm going to have 4 times 7 is 28. I'm going to divide this by 5, and I'm going to have 10. I'm going to divide this by 5, and I'm going to have a rate of Patroclus. So 28 plus 10 is 38 kilometers per hour is the rate that Patroclus is running. They didn't really say. They just said he was traveling. Okay? Now, there is your first example problem. Let me get it as close as I can so that you can see all the little parts. If you need to, you can always pause it so that you can study it a little bit. So here's example 2. Rachel has a 15-kilometer head start over Charlene. How long will it take Charlene to catch Rachel if Rachel travels at 70 kilometers per hour and Charlene travels at 100 kilometers per hour? Okay, so basically we're going to say here Charlene and Rachel has a 15-kilometer head start. So she's starting here because she's ahead and she's going here. She's traveling. Rachel is, okay, so basically I copied that one. That's an R. I copied that wrong. Okay, so Rachel is going at 70 kilometers per hour. And Charlene is traveling at 100 kilometers per hour. Okay, so now we can see that it's going to be 15 plus distance of Rachel. So 15 plus distance of Rachel is distance of Charlene. Charlene's got a lot farther to travel, 15 kilometers more, but Charlotte's going a lot faster too. Okay, so now let's put in our rate times time. So 15 plus, and then distance is rate of Rachel times time of Rachel, and then distance of Charlene is going to be rate of Charlene, time of Charlene. Okay, so now let's go back and let's put in all of the things that we know. So we already have the 15 kilometers right there, and then we are looking for the time of Charlene. That's what we're looking for. And then it says that we have Rachel at 70 kilometers per hour. So Rachel's rate is 70 kilometers per hour. And Charlene travels at 100. So rate of Charlene is 100 kilometers per hour. Okay, so Rachel has the 15-kilometer. How long will it take Charlene to catch Rachel if Rachel travels at 70 and Charlene travels at 100 kilometers per hour? Okay, so we have time of Charlene and time of Rachel. Doesn't it look like when they catch each other? So basically Rachel started here and Charlene started here, but they're traveling the same amount of time because they catch each other. One of them catches the other one. So we're going to say these two times are actually the same. So now let's go ahead. So it's going to be 15 plus 70, and we're just going to use time. Instead of time Rachel, time Charlene, equals 100 time. Okay, now we've got 70t and then 100t. Can't we just subtract the 70t and subtract the 70t over there? So we're going to get 15 is 100 minus 70, or 30t. So now we're going to divide both sides by 30. Divide by 30, divide by 30. We get t is 15 over 30. T is 1/2. 1/2 hour, since it's time. 1/2 hour is the time before Charlene catches up with Rachel. So that's your second example. Look carefully. It is correct. Make sure you get all of those parts down. And we are about to come back with example 3. Now we're on our third example, and we're about to start our practice problems. So here we have two people, and one of them is Harry, and one of them is Jeanette, and they are jogging around a track, and this track is 210. So I'm kind of thinking, you know, a track like this, an oval track or a circular track, but all the way around, the distance of the track is 210 meters. Okay, so Harry is jogging at 200 meters per minute, and Jeanette is jogging at 230 meters per minute. So she is going over the distance of the track every minute. So it's saying how many minutes before Jeanette is a full lap ahead of Harry. So here's our picture of what's going on. We don't have to draw a circular track because we know the distance around the track is 210 meters. And that Harry's distance, he will be 210 behind Jeanette, or Jeanette will be 210 ahead of Harry at the time when we stop the clock. So this is the picture of what we're looking at. So we're going to say distance Harry plus 210 is distance Jeanette. Okay, so now we remember distance is rate times time. So we can take out the DH and we can put rate of H and time of H, because distance is rate times time. And we can do the same thing over here, and we'll put rate of Jeanette and then the time of Jeanette. Now time's what we want to find out. We know that the whole problem stops at a certain time. And at that time, Jeanette will be 210 meters ahead of Harry. Guess what? That means that the two times are the same. So we don't have to have a time of Harry, and we don't have to have a time of Jeanette, because the clock is going to stop at the same time. So we don't have two different times. We already know that Harry's rate is 200. So rate of Harry is 200, and rate of Jeanette is 230. Look at that. we already have our equation ready to solve, because anytime we get to the point where we only have one variable left, we are pretty much done. Okay, so we're just going to subtract 200t and subtract 200t over here to get all of our t's on one side. So on this side, we're going to have 210. Let's see if I can get that up higher. And then on this side, we're going to have 30t. Okay, so 30 times the time is 210. Now let's just make this easier. Divide by 30, divide by 30, right there, gets our t all by itself. And since we have zeros at the end of both of those, and we're going to have 21 divided by 3 is 7 minutes. In 7 minutes, with them both running all the time, in 7 minutes, Jeanette will be a full lap ahead of Harry. Poor Harry. But that is your last practice. So now we're going to come back. Let's see if I can get it without the glare. Can you see that? I'm sitting in front of my pretty window with all the light coming in, and sometimes that makes it a little bit glary. So here we go with our practice problems. All right, here's our first practice problem. So I'm going to read it to you and let you get all the information down. Now, I've already done a chart for you. I'm hoping that you can do the chart for yourself on the second problem, but I already went ahead and made a chart for you. At 5 a.m., Napoleon headed south from Waterloo at 4 kilometers per hour. At 7 a.m., Wellington headed south from Waterloo. Wellington passes Napoleon and gets 20 kilometers ahead of Napoleon by 2 p.m. What is Wellington's rate? Okay, so at 5 a.m., Napoleon starts out at 4 kilometers per hour. And then 2 hours later, Wellington starts out, so he's got to be going faster than Napoleon, right? Because he starts 2 hours later and gets 20 kilometers ahead by the time it gets to be 2 p.m. So we're going to, again, just think of our basic equation, okay? You got to pause your video. Don't look at your basic equation. Pause your video and come back and see if you work it the same way that I do, okay? Go on. Shoo-shoo. All right, so here we go. Hopefully you've worked it and you know the answer. We're going to start with our basic equation. Napoleon's distance of Napoleon plus 20 is distance of Wellington. Okay, so we can write that without ever worrying about what their times are, because we're about to put distance is rate times time in there. All right, so then we can go and say, okay, well, we agree with that because here's Napoleon's distance plus 20 gives us Wellington's distance. So distance of Napoleon is rate of Napoleon times the time of Napoleon. And then over here, distance of Wellington is the rate of Wellington times the time of Wellington. And so now we get to play a little bit with the times. Okay, so we're talking about 2 p.m. over here, and 5 a.m. was when Napoleon started. So 5 a.m. to noon is 7 more hours, right? And then 7 plus the 2 that goes to 2 p.m. So Napoleon was traveling for 9 hours, wasn't he? So Napoleon's time was 9 hours, okay? And Napoleon's time should be 2 more than Wellington's, but let's just check it. So we're going to say Wellington should be 7, but let's just verify. 7 a.m. to noon would be 5, plus then 2 more to get to 2 p.m. would be 7. So the time for Wellington, excuse me, was 7. Now, we already know Napoleon's rate was 4. So Napoleon's rate was 4 kilometers per hour. And everything's in kilometers, so we can just put 4. So when we look at this, don't we have just one unknown? And the one unknown is the one we want, which is Wellington's rate. So 4 times 9 is 36 plus 20, and that's going to be 56. So 36 plus 20 is 56, is Wellington's weight times 7. So what am I going to do? I'm going to divide both sides by 7, right? So 56 divided by 7 is 8. So we're going to say the rate of Wellington was 8. So he is going a full double Napoleon's rate, isn't he? Okay, so we know, let's just do a little check here. We know that Napoleon was going 4. Okay, so he went 4 kilometers per hour, and he did that for 9 hours. So 4 times 9 was 36. And then Wellington went at 8 kilometers per hour, and he did that for 7. So that's 56. And aren't they 20 kilometers apart? So we checked it. So look at your work, and I will come back with your last practice problem in a moment. And we will be done with 99, and our next lesson is number 100. We'll have to have a party. All right, so here's our last practice problem. Helen has a 4-kilometer head start on Paris. How long will it take Paris to catch Helen if the rate of Helen is 6 kilometers per hour and the rate of Paris is 8 kilometers per hour? So Paris is going to start out a little bit behind. Helen has a 4-kilometer head start. So how are you going to draw this picture? I'm going to let you draw the picture. So go ahead and pause your video, and then let's see if we come up with the same picture. Okay, here is the picture that I have drawn. So if you want to think about it, you can think, okay, Helen actually starts 4 kilometers ahead of where Paris is when she starts the trip. So this is what, so maybe she's at Camp B and she's starting from here, and Paris has to start from Camp A, which is way back here. So Helen does not have as far to travel, does she? So the distance of Helen plus 4 kilometers is going to be the distance of Paris. So Paris is going to have to book it, and she does go faster than Helen does. So we know that she's going at 8 kilometers per hour, but Helen is going at 6 kilometers per hour. And how long will it take Paris to catch up to Helen? So we, again, are going to start with our basic distance equation. We have 4 kilometers plus, and we really don't need kilometers because everything's in kilometers. 4 plus distance Helen equals distance Paris. Now we're going to put in our rate times time. So distance is rate times time. So rate Helen time Helen equals rate Paris time Paris. Now it says, how long will it take Paris to catch Helen? Now, even though Helen started 4 kilometers ahead, there's no indication that they're not starting at the same time. Okay, so if this was 2 o'clock here, this was 2 o'clock here. They're starting at the same time, but one is just 4 kilometers ahead. So we're going to say, you know what, we don't need 2 different times. So we're just going to have one time t. And then we know that the rate of Helen is 6 kilometers per hour. And we know that the rate of Paris is 8 kilometers per hour. So now we have only one variable, and we're ready. So we're going to subtract 6t from both sides. And we're going to end up on the left with 4 equals 2t. And it's going to take, divide by 2 on both sides, 2 hours is the time it's going to take. So let's do a little check. Okay, we know that this distance is rate times time. If the time is 2 hours, then Helen's distance is going to be 2 times her rate, which was 6. So she's going to travel 12 kilometers plus the 4 that was left over. So the total would have been 16 kilometers. And let's make sure that that winds up being Paris's distance. So 2 times 8 is 16. So it works. All right, there is your last practice problem. And you are ready to go and do your homework. And this is Mrs. A. And may God bless your day.